Okay, so this brings us to part 2 of the course, which is all about motion, okay? And we'll ask the question of why things move and how things move, right? And it brings us to introducing the very important concept of forces, okay? So that will be our chapter 2. So this is what I call it. I call it with a subtitle, right? It's the theory of motion, right? So forces is sort of the origin of how do you have motion. Okay, so it answers questions of why things move and how things move. Now, on first thought, it sounds like a very dumb question, right? Of why things move and how things move. Well, if it moves, it moves. Why do you even have to think about this? Now, let me challenge your perception of that statement a little bit. And this is by one of the Greek philosophers, Zeno, who already have some doubt that this is not on surface as simple as it thinks. Because so this is Zeno, which has a version of it, but it's called Xenos Paradox. Okay. A paradox is something that that doesn't make sense, right? So it sounds like it makes sense, but if you give it a little bit more thought, it doesn't make sense. So what did he thought about? He thought about this. He was thinking, how is it possible for things to move? Well, it sounds like a silly question, but hang on to that, right? If you think about it this way, if I want to move from point A to point B, right? I want to move around just a straight line, very simply, right? I just want to move from point A to point B. In order to achieve that, I will need to go through the halfway point, right? I need to go through, let's say that's 1 mile. You need to go through half a mile. But in order to go through half a mile, you need to have gone through a quarter of a mile. You have to go through a quarter of the distance before you reach that. And before you reach that point, you have to go through 1/8 of the distance before you reach a quarter of the distance, right? And I know this gets a little bit boring, but you can keep going. Now, my question to you is, how many points, if you keep halving this, there is? Well, technically, space is continuous, right? So there is infinite amount of points that you have to go through in order to reach point B. You have to first reach a half. But to do that, you have to first reach a quarter, and then 1/8, and then 1/16, 1/32, 1/64, like this, and this infinite amount of points. Now, reaching each point does take time. So how is it possible you can go through an infinite amount of points in a finite amount of time, right? Let's say you walk in a very leisurely pace of 1 mile per hour, right? So in principle, on naively, you would think, well, to go through 1 mile, it will take me an hour, right? But if you think about it, there's infinite amount of points, so it should take you infinite amount of time. This is a very deep question. It sounds like a stupid question, but it's actually not easy to resolve this paradox, and it takes after years of people thinking about it, it finally takes a genius of Newton and other scientists and mathematicians who thought about this and invented the theory of calculus. That is finally the only way to resolve this, or I should say a complete way to resolve this paradox. This is not only thought by the Greeks, it's also thought by ancient Chinese. It's called the arrow paradox. It's the same idea. People thought of, if I shoot an arrow from here to there, it has to first go through a half of the distance, and then a quarter, and then at 1/8. So how is it possible that things even move? And Zeno concluded, rather interestingly, he concluded that motion is just an illusion. Nothing actually ever moves. The reason we see things move, it's a complete illusion. I don't think he has a proper answer to why do we see things move. And I think it falls along the philosophy of his philosophy that all motion is an illusion. It's a perception. It's everything that happens in our brains, right? Well, from the most modern point of view, we know that that's not true. Things do move, but it's a very delicate way to explain why. So unfortunately, although I'm teasing you we will not be able to answer why. That's that's a very deep philosophical question, and it takes much more mathematics to deal with that. But we will study how, right? So just want to point out this is not as trivial as it sounds. If that's interesting to you, I'll show you another paradox that Zeno used to think about. It's called Achilles and the Tortoise. So is this guy, right? This Achilles, right? Very well healthy runner, and is racing with a tortoise, and he's very generous and gives the tortoise a head start, right? So the tortoise will start, let's say, 100 meters in advance, right? And they're going to race, and of course Achilles is going to run much quicker than the tortoise. Well, can he ever catch up to the tortoise? Well, you would think so, but let's think this through again, right? So at some point, if Achilles has to catch up with the tortoise, he would have to arrive at the point where the tortoise used to be, right? He have to pass that point in order to catch up with the tortoise. But at that point, whatever time, I don't care how much time it took, a minute or half a minute, 10 seconds, whatever, the tortoise would have moved a little bit further along at a slower pace, right? Not so much, and tortoise is working its way through. But it will be a little bit further, right? So when Achilles is here, the tortoise would be here, right? But now, if you keep thinking about this, right? So Achilles will, in order to catch up, he will need to have gone to where the tortoise now is, right? So by the time Achilles is here, the tortoise would have moved a little bit further, right? Albeit not so much, right? Just a little bit, right? So Achilles would have covered much more distance than the tortoise had, but still, the tortoise would be ahead of him. Now, I can repeat that, and Achilles, every time, in order to catch up with the tortoise, he would have to have gone through, there's no way he can skip ahead, right? He'll have to pass through this point. But the moment he passed through this point, the tortoise have already been there, right? The tortoise would have been in front of that point. So it would have been a little bit further, and I can keep on going. So no matter how fast you run, Zeno concluded, you will never be able to pass a tortoise. So that's his second evidence that motion is just an illusion. Well, let's not go down this rabbit hole or tortoise hole. But if you are interested in this, you can look up, go to Wikipedia, look up Xenos Paradox, as I've written there, and search plenty of good YouTube videos on fun YouTube videos that discuss about this. Anyway, we won't worry too much about the why, but we will talk about the how.